All right, let's get right into it. Every single time you open a website, something totally invisible but absolutely critical is happening in the background. We're going to explore this hidden system that basically acts as the Internet's global address book, the Domain Name System, or DNS.
I mean, really think about that for a second. You type a simple name, and out of literally billions of computers all over the world, your browser finds the one, single, correct machine almost instantly. How on earth does it do that? Well, that's the puzzle we're going to piece together today.
The whole system really just boils down to solving one big problem. You and I, we speak one language, and computers speak a totally different one. We need a translator to bridge that gap, and you guessed it, that's exactly where DNS comes in.
See, for us, it's all about names, right? We remember things like Google.com. It's easy, it's memorable, it's just how we're wired. We think in words, not in long, complicated strings of numbers.
But computers? Oh, they couldn't care less about a friendly name. They live in a world of pure logic and numbers. They need a specific numerical address, an IP address, to find anything on a network. That's their side of the conversation.
And right there, that's the magic trick of the domain name system. It's this essential service that takes the name you type and, in a flash, swaps it for the IP address the computer needs. It's really the engine under the hood that makes the internet actually usable for us.
I mean, can you actually picture that? Forget typing in website names. You'd have to memorize a unique 12-digit number for every single site you ever wanted to visit. It would be a total nightmare. The web would be completely unusable. DNS is what makes it all feel so effortless and, well, human.
Okay, so how does this translation actually happen in that split second? Let's follow the journey. It's this surprisingly slick 7-step dance that your request goes on every single time you click a link or type an address.
So, the moment you hit enter, the hunt is on. First, your browser checks its own memory, its cache, to see if you've been to this site recently. Think of it like checking your phone's recent calls list. If the address is there, boom, you're done. If not, it asks the next level up, your computer's operating system. The OS keeps its own little stash of recent addresses too. Still no luck? Okay, now the request leaves your computer for the first time. It goes to your DNS resolver, which is a powerful server usually run by your internet service provider like Comcast or Verizon. Now this resolver is our hardworking detective. If it doesn't already know the answer, it starts the real quest. It asks a root DNS server. This is like the master index for the entire internet. And get this, there are only 13 of these root server systems in the whole world. The root server won't know the final IP address, but it knows who to ask next. It points our detective to the right top-level domain server, or TLD. This is the big directory for everything that ends in .com or .org. You get the idea. That TLD server then points to one last place, the authoritative DNS server. This is it, the final source of truth. It's the server that holds the official record for that specific website. It hands the correct IP address back to our detective, the resolver, who then passes it to your computer, and at last your browser connects and the website loads. All of that in the blink of an eye. It's wild.
Okay, so that's the how. But what about the so what? Let's talk about why any of this actually matters to you. Because this isn't just some technical mumbo-jumbo. It has a huge impact on your everyday internet life, from speed to security.
Yeah, after hearing about that 7-step journey, you've got to be thinking the same thing I was. If all that is happening for every single click, for trillions of requests a day, how is this not painfully slow?
The secret, and it's a really clever one, is caching. It's basically a cheat sheet. Your browser, your computer, and the resolvers all remember the answers to recent lookups for a little while. So the next time you visit that site, you can just skip almost the entire journey. This simple act of remembering is what keeps the entire internet feeling snappy and fast.
But, whenever you have something this important, this central to the whole operation, well, it's also going to be a target. Think about it. If a bad guy can mess with the address book, they can control where you go.
So attackers use these sneaky tricks like DNS spoofing or hijacking to try and fool the system. They can basically jump in the middle of your request and feed you a fake IP address, sending you to a malicious website that might look exactly like your bank's website, all to try and steal your info.
To fight back against this kind of thing, security protocols like DNS over HTTPS or DOH were created. The best way to think about it is this. It's like putting your address request inside a sealed, encrypted envelope. It stops anyone from snooping on or changing your request while it's in transit.
So what about when things just break? We've all seen it. That dreaded error message when a website you know should be working just won't load. What's actually happening when the address book itself seems to be broken?
Well, here's the thing. When you see this error, it almost never means the internet is down. The website you're trying to reach is probably online and working just fine. It just means your device, well, it can't find the map. The phone book is temporarily offline, so your browser is completely and totally lost.
So when you put it all together, you really start to see DNS for what it is. It's this silent, absolutely essential guide for the entire internet, just humming along in the background, translating billions and billions of requests every single day.
And I love this quote because it just hits the nail on the head. Without this system, the internet as we know it simply couldn't exist, period. It's the ultimate navigator that connects our human words to the vast digital world, telling all that data exactly where it needs to go.